So it would be, you see, if I use the labeling, I'm going to drop it at some point, but from physics, it would be on the block by the Earth. That's the weight. We have the force here. So the force on the block by, I don't know, some hand or whatever. And what else?
The normal force.
The normal force acting on the block by the ground. Just as a quick review, can I say that these two form a third law pair?
No.
Remember, that's not the case. You can never ever have two forces on the same free body diagram that make a third law pair. Why? It's because the third law reads this way: FAB on FBA. And we know that these two are equal in magnitude and opposite in direction. That can never happen on a free body diagram to see these two forces. Because on a free body diagram, the forces always start with the same layer, because it's the forces acting on the object. So never ever will you see two forces on the same free body diagram that make a third law pair. So that cannot happen. These are equal and opposite. That's true, but for a different reason. Why are the normal and the weight equal and opposite?
Because the net Fy force is 0 and they're the only two y forces acting.
That's right, there is no motion along the vertical, therefore there is no acceleration along the vertical. So then the sum of the forces along the y-axis is equal to 0. So that's why these two are equal and opposite. But it's not because they form a third law pair. Not at all. This is not true. And I'm just quoting that because it's a common misconception at the beginning of physics. But you've taken physics, so you give me the right answer. Okay, so then you see, using an x-axis and a y-axis, we know that the motion is, if I go through the details, it's along the horizontal, so we have A in that direction. So if I say F net is equal to MA, and I write this along, well, if I look at the x component, so this is what matters here. I'm just going to get the force by the hand is equal to the mass times the acceleration. So since we know the force is 2.5 t, we can get the acceleration Could you take your phone calls at outside of class? Can you take your phone calls outside of class if you have something? You're still nearly done. So I can say 2.5 t is equal to the mass times the acceleration here. And a mistake not to make is to say that the mass is equal to 10. No, it's equal to 10 over 32.2. So you find that the acceleration then is equal to 8.05 t.
Just so I'm sure, the book's always going to give pounds as pounds force, right?
Yes, never as pound mass. Well, it will make a difference, because if you see pounds, it means that the weight is that many pounds. So from that you get the velocity. Don't forget to add the constant. So that t equals 0, the velocity is 10. Then you get the distance covered say x. So this gives you 46.2 feet per second, and this gives you 66.2 feet.
Má là theo trường nào đó thì SAT.
So that's all there is to say. So we'll continue working on the F equal MA tomorrow. So for Friday, for the exam, there will be two problems as usual. One problem is going to be relative motion. So remember we did one of them, which was the boat crossing the river. And another problem is going to be something like F equal MA in rectangular coordinates.
Nhớ mua rau muống cho tôi nha.